Okay, we'll talk a little bit about some of the digital modes, which will send digital data as opposed to voice. We mentioned packet radio. It was one of the first digital modes. You're probably familiar with IEEE 802.11, but not necessarily that nomenclature. That's basically Wi-Fi, which is a digital networking protocol. One of the newer things and more popular, and I mentioned a couple times, is FT8, which is a digital mode for making weak signal contacts. It was developed by a guy named Joe Taylor, who, if I remember right, I think he worked for Bell Laboratories, but he did deep space communications research. And he developed protocols that would enable communications with these satellites that are going, outside of the solar system. Extremely weak signals. So they adopted some of those protocols and created this suite of software programs that amateur radio people use. And one of the more popular ones is called FT8. It's called FT by Frank Taylor. There was another guy that worked with him, and I forgot his first name, but something Frank. And the 8 means that it uses 8 symbols. It uses 8 tones to represent 3 bits of digital data. And it has a bandwidth of about 50 hertz. And you can actually decode signals that are as low as 24 dB below the noise level. There's signals you can't even see on the spectrum, but the computer is able to decode them. There's PSK31, which is a radio teletype type of mode where you do keyboard to keyboard. Instead of talking, you just type back and forth.
Like texting?
Like texting. It's the old-fashioned texting where you did a teletype.
Yeah.
This is radio teletype and a digital version of it. There's a thing called APRS, which is Automatic Packet Reporting System. And in some radios can do APRS, and they send out your GPS coordinates along with some other information. And you can use it and there's programs that you can, kind of like the satellite tracking programs. There's one that shows APRS data, and you can track people. If they're, have a mobile installation and they have APRS, you can actually see where their car is. We have a 10-kilometer race every year over at the Space Force. And we use it there to keep track of, we have a lead car and a following car for the runners, and they have APRS so we can see where they're at. It does require a computer to do all of these things. However, there are some transceivers that can do some of this internally. I would say the majority don't, but you can do some of it. So which of the following is a digital communications mode?
All of them.
All of them. Okay, we talked about packet radio, so you send messages as packets, just like you're sending a letter. Depending on how long the message is, it may require more than one packet. So each one of the things when that happens is each packet has a sequence number, because it's possible they could be received out of order. Mm-hmm. Like you may have to resend a packet because of an error. So the receiving station has to be able to put them back in the right order. So that's why they have a sequence number. They can be broadcast as opposed to just sending it out to a single addressee. If you're talking to satellites, they can be in a store and forward mode, where as the satellite comes over, you can send the packets and it stores them until it gets in position of the receiving station, who can then download the packets. The packet contains a checksum, something different than when you send a letter. It's just, most simple checksums are just adding up all the bits and coming up with the number. So the receiving station does the same thing and verifies it comes up with the same number. If it doesn't, it'll send back an ARQ, or an automatic repeat request, saying, the packet was bad, resend it. And that can happen several times. Usually there's a limit and it can be changed, but after 3 or 4 attempts, it usually gives up. Here's what a typical packet looks like. So you have usually some kind of sync pattern to figure out where the beginning is. You have header information, which is going to tell you where it's going and who it's from. You actually have the data, and inside the data, you may have additional header information and an additional checksum, and then a checksum or a more sophisticated check block, perhaps. Which of the following is included in packet radio transmission?
Delta.
All right. This is talking more about automated repeat request. So that if the checksum doesn't pan out, the receiver sends the ARQ back, and the sending station will resend that packet. Like I said, it may happen 2 or 3 times. That's something that can be changed. I think the default is like 3 typically.
Mm-hmm.
So what is an ARQ transmission system?
Charlie.
APRS uses packet radio. One of the things that's in the packet is GPS information, so that you can track the position. Mm-hmm. Sometimes there may be text and possibly some weather information as part of it. But the basic thing is it's for position tracking of wherever the transmitter is. Here's one of the typical APRS maps. Happens to show where I am, because when it's on, one of my radios sends out APRS packets.
Oh.
And you can see, I believe there's a boat up here A lot of times you'll see them on marine boats. In fact, there's a lot of boats there. I don't actually see any cars, but usually if there's a car, it looks like a little car symbol. You can see where they're at. So which of the following is an application of APRS?
Alpha.
Yep.
What kind of data can be transmitted by APRS?
I say Delta. If you want to call them text messages.
Alpha.
Well, it can be text.
It could be weather data too, right?
Yep.
Oh, you were right.
Yeah.
Okay. PSK31 we mentioned. I don't know that it's that popular anymore, but it was popular. It's called PSK because it uses phase shift keying, not amplitude modulation or frequency. We mentioned FT8 before. FT8 uses frequency shift keying. PSK uses phase shift keying, which is slightly different, where you send out the binary representation by different phases of the waveform. So in case of binary phase shift keying, you'd send out two different phases or phase shifts, as opposed to when we talked about the mark in space, where it was two different frequencies. It's the same kind of thing, except there's two different phases of the waveform. And the encoding that's used for characters, instead of being your typical ASCII code, which stands for the American Society for Communication Information Interchange, it uses what's called varicode. And varicode is variable, whereas ASCII is fixed. Can be up to 8 bits, but every letter or number has the same number of bits. In the case of varicode, the most common letters use the least number of bits, and the least common use the most number of bits. And hopefully, see if I still have that chart in there. What does the abbreviation PSK mean?
Bravo.
Oh, maybe I don't have my varicode chart. Anyway, I have a chart that shows a lot of the different letters and what the binary code that gets sent, and it's only like for the vowels, it'll only be 2 to 3 bits to send the vowels, where things like the very least used letters may be 6 or 7 bits long. So it makes it more efficient because it's using less bits for the most commonly used letters. A number of years back, they started doing digital radio. There's essentially 3 different types that are kind of proprietary to different manufacturers. Digital mobile radio, or DMR, is one of the more popular ones because most of the Chinese-made radios support DMR. Not the cheaper ones. They usually cost $100 or more for a DMR radio. And it does digital voice. digital FM, actually. It uses what's called time division multiplexing because it can send 2 channels. And it's 12.5 kilohertz wide, and you have these 2 voice channels. Typically, only one is used, but the capability is there for having 2 at the same time. Essentially, it allows you to use to go through a gateway and repeaters into the internet, and then come out the internet to another, gateway repeater somewhere else. You can create what's called virtual channels, or they call them talk groups in DMR, where there's a lot of them that are already set up. You can actually create one of your own, and it's like a private little group. When you join that group, only people that belong to that talk group can hear one another. It's not really private, but it's not like everybody in the world hears you. Only people in the talk group.
Is that like when they have like channel A, B, C, that kind of stuff? And they want people to.
No. The talk groups will have, in the case of DMR, their numbers, and there's a thing you can look up that shows all the different talk groups. You have to program your radio for the different talk groups, and then you have to link to whichever one you want. And then you can talk to people in that talk group.
Gotcha.
There's ones that are in different countries. There's local ones. There's like West Coast Florida and East Coast Florida, and I think there might even be some even more local ones around here. I haven't used DMR in a long time, but essentially,
it reminds me of when you'd have back in the day, party line where
yeah I remember.
except here you can make a smaller.
We're giving away how old we are.
I know it. And it's funny how we have to make these analogies to try to understand this.
I remember going to my one of my aunts, and you had to crank the phone on the wall.
Oh, wow.
To give the number of rings for whatever your party line was.
Right.
And she always, whenever the phone would ring, she always go listen to whoever.
I was going to say the difference is that everybody could listen to the party line. It was really just a courtesy that they didn't.
Right. What was aggravating is when you just get on and they're constantly picking up to see if you're off yet so they can make their calls. Like, I just got on.
Click, 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 click.
Yep.
Okay, so which of the following describes DMR, or digital mobile radio?
Alpha.
Alpha. Mm-hmm.
What is a talk group on a DMR repeater?
Bravo.
Bravo.
Okay, we talked about the digital modes, and I mentioned the software suite that Joe Taylor developed, and it's called WSJTX, which stands for Weak Signal Joe Taylor version X. There's lots of different programs within that suite of software. There's one for what's called EME, or Earth, Moon, Earth, or Moon Bounce. I believe it's called Echo, where you can actually beam a signal and bounce it off of the moon to somebody else, possibly halfway around the Earth. There's modes for doing meteor scatter, MSK 144, where you can bounce signals off of the ion trails left by meteors coming through the atmosphere.
Oh, wow.
There's one called Whisper, or Weak Signal Propagation Beacons, which the pico balloons use. I don't know if you've heard about pico balloons.
No, but the Pico I know has to do with federal funding. So,
No, this is pico meaning small, where there are. I've had a few launched. They're like 1 meter diameter, kind of like party balloons, except these are
uh-huh.
made out of
I've seen a
mylar,
couple of those go up. Yeah.
and they have a uh, solar panel and a little transmitter that hangs down below it in the middle of a dipole antenna. The ones that I did were running at 20 meters. They go up to 45,000 feet. I had one that made almost 8 trips around the Earth, and it sent out Whisper protocol. And just like the APRS and the others, there's some kind of tracking programs that you can bring up and see, where your balloon is. They transmit about I think it was like every 10 minutes. It's kind of neat to see, and when they get caught in the jet streams and things, they can go 200 miles an hour, which
Or
is
for more.
amazing. Think of a little party balloon whipping at 200 miles an hour. They can also get caught in a vortex and go 1 mile an hour in a circle.
Ugh.
So down here is a lot of the different programs that are in there. I mentioned Echo and Whisper and MSK 144, FT8. There's a FT4 version, which uses 4 tones to represent 2 bits. It's faster than FT8, but it doesn't decode to the same level. These other variations, I haven't tried FSTs. There's some of the JTs, which are more like keyboard type. But of all of them, FT8 is probably the most popular. Even though you don't get to talk to anybody, you just it's somewhat like contesting. You make a contact and you exchange signal reports and grid square and call sign. That's basically it. But even with a standard 100-watt radio and a simple antenna, it's possible to make contacts to Australia, New Zealand, China. Here's one of the Whisper maps. It shows all the different. There's a station in this conglomeration up here that's transmitting, and it's showing all the different stations that are receiving that signal. You see a similar thing with the balloons, and it'll show you the footprint of the balloon like you saw with the satellite. And it was like 200 miles because of the curvature of the Earth. It'll show all the stations that are receiving the balloon signal. Which of the following operating activities is supported by digital mode software in the WSJTX software suite?
D. Delta.
What is FT8?
Bravo.
I didn't hear that. What'd you say?
Oh, I'm sorry. Bravo.
Okay. Yeah, don't let that 8-channel fool you.
No, I didn't. I got down to that. It's a low signal to noise operation.
Yeah.
Right. There's another thing that's becoming more popular called mesh networking, where people take some commercial Wi-Fi routers and load different firmware in them and can put up a network of them that can communicate with one another in kind of a mesh, so that you can communicate over a wider area, and they have multiple paths. So if one of them goes down, you can still find a way to get from point A to point B.
Bob, I'm going to sign off now, and
Okay.
I'll listen to the rest on the recording.
All right. I think we're
Thank you.
close to the end anyway.
That'll be better. All right, so long.
Okay. They can do high-speed emergency communications because of kind of the fault tolerance, since there's usually more than one path to get from point A to point B. There's some kind of standard ones called broadband HEMNet and the amateur radio emergency data networks that are set up as mesh networks. So which of the following best describes an amateur radio mesh network?
Alpha.
Yeah, the key is the modified firmware.
Mm-hmm.
Okay, so yeah, we were almost done.
Oh, you just needed to finish. You were 5 minutes. Not even.
We talked about the different digital communication modes, packets, and internet, or Wi-Fi, FT8. In the packet, it has a checksum and a header, and ARQ for repeat transmission, APRS for basically tracking position of things. Can be boats, cars, people, runners. Yeah, in fact, a couple years we had one of the runners had a radio that had APRS, and we could actually track him.
Wow.
PSK31, I would say, was popular on HF. It uses phase shift keying. That's what the PSK stands for. And the 31 is 31 baud. So it just uses different phases instead of tones. We talked about DMR. We didn't really talk about the other two, D-Star and Fusion. And D-Star is essentially ICOM and Kenwood radios. Fusion is Yaesu. None of the three can directly talk to one another, which is typical. I mean, they do the same kind of thing, but in essence, they're proprietary.
Gotcha.
DMR has what they call talk groups. In the case of D-Star, and I believe Fusion, although I haven't used Fusion, they call them reflectors, same kind of thing. It's just, a group. The WSJTX suite has a bunch of different modes that we talked about, and mesh networks.